Let's do one more example from section 3.1. Problem 12 on page 124 gives me a function, f of x is equal to x minus 2x squared and a point 1 comma minus 1, and asks me to find the slope of the function's graph at the given point. Then find the equation for the tangent line to the graph there. Alright, so first off, I need to find the derivative at x equals 1. All right, so this is the limit I'll be dealing with. I need to plug 1 plus h in for x. Minus f of 1, well, I could just go on and plug that in, but they already told me what the y value was, so I'll just write it down. In fact, I've always kind of thought this was silly that the author gives us both the x and the y. All he needs to give us is the x, because I plug that in and the function gives me y. That's its job. But here's the problem I have. I have to evaluate this limit, and I'm in the situation again where I need to try to cancel an h out. So let's do the arithmetic on the top and see if we can find a spot to cancel out that h. All right, so I got to multiply out the 1 plus h all squared. All over h. All right, and that's equal to, let's see, the limit as h approaches 0, 1 plus h, and now I have to distribute. Minus 2 minus 4h minus 2h squared, and I still have this plus 1 over here. 1 plus 1 is 2 minus 2 more. Those three things cancel out altogether, so 1 plus 1 is 2 minus 2. That leaves me with h minus 4h minus 2h squared all over h. I could imagine factoring an h out of the top and canceling the h on the bottom. Reducing all of the powers of h by 1, I now have this statement. And I realized that if I went all the way back to right here, I had some like terms I could have combined, but I didn't catch that. That's okay. I still have the like terms. 1 minus 4 is minus 3. Minus 2h, but if h goes to 0, so does 2h. Leaving me with f prime of 1 being minus 3. All right, so minus 3 is my slope. Now I'm supposed to find the equation of a tangent line. When we started section 3.1, we said the tangent line was the line going through this point on the function with that slope. So now, the equation of a tangent line, y minus y1, so minus a minus 1 is a plus 1, is equal to minus 3 x minus 1. Distribute that minus 3, take 1 away from both sides, and here is my nice happy tangent line. Y equals minus 3x plus 2. All right, there's my equation of the tangent line. There is the slope of the curve at that point. And we've completed the problem.